Okay, in this lesson we are going to figure out how to find the area between two curves. Okay, so for this first part, we are going to start out by graphing our function that's given to us here, and that function is sitting right here, so we definitely need to graph that. Okay, so from looking at our vertex of this, we do need to remember that our vertex can be found inside here. So we need to go right 2 and up 6. So that's going to put our vertex at 2, 6. And then we need to pick a point somewhere and pick a value, plug in, and get us a point. So let's pick just over here to the side. I'm going to pick 4. So let's calculate f at 4. And if we do that, we have negative 1/2. That's going to be 4 minus 2 all squared plus 6. And mental math that, no need to show all your work for it. So that's going to be 2 squared is 4, negative half of 4 is negative 2, and plus 6 is going to be 4. So we have the ordered pair 4, 4. So we're going to go over 4 and up 4. And remember that this is a parabola. This is your axis of symmetry through here. So then if you went over 1, 2 and was up 4, then you can go back 1, 2 and then up 4, and then you would also have that point there. And so you've got a parabola here. And again, just a rough sketch is fine. Do the best you can with it. And notice that it wants us to find this value for part B. We want to integrate that, which means this is wanting us to find all of this region down below here. If you integrate, you're finding all of this bounded area. Alright, so to find that area, we need to integrate. So we're going to integrate from 0 to 5, and you're welcome to use your calculator here. Negative 1/2 x minus 2 all squared plus 6 dx. And we can integrate with our u substitution here. And that's just going to give us an x there. So we're going to have negative 1/2, and then that's going to go up to x minus 2 all cubed. And then we're going to have plus 6x. And then all of that is going to be evaluated from 0 to 5. And by all means, please use your calculators here, and you should get 145 over 6. And now it wants us to shade that region blue, which I already did. I got ahead of ourselves here. Now look at part D. Part D wants us to graph this line. So graphing our line, I'm going to graph that in green. Graphing that, remember that this is going to be your y-intercept, so we're going to go back over here to 4, and negative 1/2 is our slope, so we're going to go down 1 over 2 and put a point, and then down 1 over 2 and put a point, and we can do one more, down 1 over 2. It's kind of out of the region there. And we're going to connect our dots, and that's going to be our line for us. Okay, so notice it's kind of cut that region, not necessarily in half, but it did cut it into two different pieces. Now it wants us to find the integral of g of x. So let's come over here to the side and do that. And again, you can use your calculators here. We're going to go from 0 to 5. 4 minus 1/2 x dx. Okay, and then we are going to, I'm going to slide this up a little bit. So when we integrate that, you should get 4x minus 1/4 x squared. And that's going to be integrated from 0 to 5. So notice it's the same endpoints. And again, please use your calculators here, and you should get 55 over 4. Now, F, they tell us to shade the region in green that we found. So I'm going to go back and take my green marker, and to shade in green, notice what we found. That's this bottom area because it's bounded between that function and the lower part. So there's the green part. So our question is, how would you find the area that's between the two? So in other words, I need to find this bounded region. That's what I'm looking for to find. And hopefully the idea of subtracting the two areas would come to mind. So in example 2, we're going to go through and subtract the two. Now please don't subtract the two values that you got up at the other in example 1. That's not what you do here. You've got to subtract, and it's going to be the difference inside the integral. That's going to play a little bit different part here, and it's not going to give you the values you would think. So to set this up, what you're going to do is say the integral from 0 to 5, and your function f of x, which was negative 1/2, times, and you have x minus 2 all squared plus 6. So there's your first, your f of x, minus, and then your g of x, which is 4 minus 1/2 x. And now your d of x. There's the right way to set this up. Don't change it. Don't mess up your parentheses, because most of this, your points will come from setting this up properly, making sure you have all the parentheses in the right place and your dx at the end. Now let's go through and start writing this out, and this is where you're going to have a lot of algebra here. You're going to have negative 1/2 times, and you're going to have x squared minus, we're going to pull this out, 4x plus 4 plus 6, and then minus 4 plus 1/2 x dx. Notice a lot of terms here, so be careful with it. So we have the integral from 0 to 5, and we have, and let's distribute now, negative 1/2 x squared. And we can do some of this in our heads. That's going to be negative 1/2 times negative 4, that's positive 2. And then you've got another 1/2 x out here, so that's going to be a positive 5/2 x. And then we have negative 2 here. And then, let's see, we've got negative 2, and then 6 is positive 4, and then negative 4. Those all cancel out, and you're left with dx. Now you're ready to go ahead and integrate. So if you integrate negative 1/2 x squared, that's going to give you negative 1/6 x cubed. And then if you integrate 5/2 x, that's going to give you, if we add 1 to the exponent, that's going to give me a 2, and that's what you divide by. So that's going to give you 5/4 x squared. And that's going to be all of that's evaluated. Need to put parentheses there, from 0 to 5. And again, please use your calculator here, and you're going to get 125 over 12. Okay, sometimes we have curves that intersect in more than one place. This is a good example here in example 3. So we have to find points of intersection before we go through and integrate. So the first thing we need to do is find where they intersect. So in order to do that, you set the two functions equal to each other, and you solve for x. So we have 14x plus x squared minus 2x cubed equals x squared minus 4x. Now you want to locate your highest exponent and make sure that term's positive. So I'm going to move everything over to the right side. So there'll be a 0 left here. And so I'm going to have a positive 2x cubed. And then if I move my x squared over, those will cancel. And then subtracting 14x over, that's going to give me a negative 18x when it combines with 4x. So now we're ready to take out our GCF, greatest common factor. So 2x, that's going to leave me with, not a 2 there, goodness, dope head. Alright, so it's going to leave me with x squared minus 9, that's much better. And then if we finish factoring this, we have 2x times x minus 3 times x minus, or plus 3, goodness. Setting each part equal to 0, we see that the x values are going to be 0, 3, and negative 3. Now we need to find the points of intersection. So that means that we need to find f at 0, what that is equal to. We need to find, or we could do g. It doesn't matter which function. It looks like g would be a little bit easier. So I'm going to go back and change g or f into g, because it's a little bit easier function to work with. And then g at 3, and then g at negative 3. And again, you could choose either function. I'm just choosing g because it's shorter. That's the only reason. Alright, so g at 0, and we can do mental math here. If I plug in a 0 for x, that's going to give me 0. And so in other words, I should have my two functions crossing right there at 0, 0. And I see graphically I do. And then plug in a 3. So mental math here, if I plug in a 3, that's going to give me 9 minus 12. So that's going to give me negative 3. So over here at positive 3, I should have a negative 3, and that looks like it's about what I got. So 3, negative 3. And then if I plug in a negative 3, well, I'm still going to have a 9, but that negative 12 is going to go to a positive 12. So that's going to give me a 21. So way up here, and it looks like from the graph that's going to be correct. I've got negative 3 and a positive 21. So I found my points of intersection. Alright, now I need to write the integrals and calculate the area. And this is going to be a little bit lengthy here. So we've got two areas. Let's identify those areas. So the first area that we have is this area here. That's going to be the first one. And remember, it's the top function minus the bottom function. And let's see, the second function, or second region, is over here. And notice what happens. In area 1, I think I need to go back to the pen. Here we go. Area 1, notice the quadratic function, or that squared function, is on top. So whenever I write this, when I integrate it, it's from what x value to what x value. My x value is negative 3 to 0. And it's going to be what function's on top, which is going to be x squared minus 4x minus the function on bottom, which is this cubic function. It's this portion right here. So that's going to be 14x plus x squared minus 2x cubed. And then don't forget your dx. That's going to be the setup for area 1, and we need to label that area 1 equals. And then for area 2, well, that's a little bit different. Area 2, you're going to integrate. This time you're going to go from 0, because it's what x value to what x value. So 0 to 3 this time. But now look at what's happened to your functions. They have swapped. And that usually happens. That's why they're intersecting, is because they're switching positions. So you're going to have your cubic function. So 14x plus x squared minus 2x cubed. You're going to take that cubic function minus your quadratic function. So x squared minus 4x dx. That's going to be your second area. Now I'm going to give y'all the answer. Each individual one, this one is going to be 40.5. Now if you're not successful in getting that, and yes, you may use your calculators, please come see me and I will try to find your mistake in it. And so your total area for this and I do want you to try it, your total area is going to be 81. But I want y'all to try it and see how you do with it, because the rest of it is just integration. Alright, let's go on to our next problem. Alright, so now with this next problem, you really have got oscillating functions here. And let's see, goodness, we are intersecting. Need to change colors, hang on. So you're intersecting here, and it looks like it goes to here. And this looks like sine and cosine functions. And so notice it tells us we're just wanting to find just one of the regions. Alright, which is good because it looks like they keep overlapping each other. So let's label, it says f of x is going to be greater than g of x. So which function is going to be on top? So that's looking for your top function. And it looks like the one that's going through 0, 0. And so that's got to be our sine function. So we're going to say sine of x. And the one that's going to be below, that's the one that's going to have 0, 1 as its starting point, and that's got to be cosine of x. Okay, and find bounds A and B where sine of x is equal to cosine of x. Well, if you know your ordered pairs from that unit circle, sine and cosine are equal to each other at pi over 4. I know everybody says root 2 over 2, but we need those radian measures of the angle. And then it's also going to be down in the third quadrant where it's negative root 2 over 2, which is 5 pi over 4. So we know those values. And now we're going to find our area. So the area, and then keep in mind, we always have to remember what are we finding. And we're finding this bounded region right here. And that bounded region, we're going to integrate from pi over 4 to 5 pi over 4. There's your region. And it's going to be your top function, which is sine of x, minus your bottom, cosine of x dx. Alright, so I'm going to give you the answer, and again, you try to integrate it. The answer to this one should be 2 root 2. And that's what I got. But I want y'all to try this, provide the work for it. Alright, now the next one. We're going to turn this on its side, and we're going to work, instead of in relation to the x-axis, we're going to work to the y-axis. Yay, we're turned sideways. And so, notice here, this is going to be, everything is turned sideways, is kind of what it looks like. And so this is going to be the y-axis approach. Everything is in terms of y. Notice your two, now these are no longer functions. Notice how they're written. It's x equals. It's no longer a y equals. And so you're going to have to use a horizontal rectangles, which is what we're doing, is adding up millions of little rectangles. So what we're really doing is taking this function way back here and we can call that f at y. And we're going to find the difference in that and g at y. We're finding that. So the bounded region is going to look like this. It's that region inside there. That's the area that we're finding. All right, and so here, whenever we're going to go through and set this up, notice that with this, we're going to use our different endpoints. And with our endpoints, let's see, did they give us our endpoints? Well, they did. They gave us our endpoints. It's going to be -2 to 1. So we're going to go from -2 to 1. If not, you would find them the same way by setting your functions. Notice it's x equals stuff, so stuff has to equal each other. And you would solve for y instead of solving for x. It's the same thing. Now, let's see which one is further right instead of which one's on top. It's which one's further right, and it's the one that's a parabolic shape. So we're going to say 3 minus y squared, and then minus y plus 1. And then we're going to say dy because we're in terms of y now instead of x. And so we can put some of this together again from -2 to 1. And if we put this together, we're going to have 2 minus y squared dy. And then the rest of it is just regular integrating. And your answer for this should be 9/2. I want you to work it out, and if you can't get it, let me know, and I will work it out, but I want you to try it first. All right. So that's all of your notes. I want you to go back, take the time remaining, and fill in all of these places where I just gave you the answer. And seriously, if you cannot get it, please ask me about it in class, and I will be happy to work it out for you.